Hey, welcome. Today, we're going to open up the toolbox of data science. But don't worry, we're skipping all the intimidating algorithms for now. Instead, we're starting with the real basics, the foundational tools that help us turn all that noise out there into actual meaning, one simple piece at a time. So, let's get into it. We're living in a world that is absolutely swimming in information. I mean, every time you click something, buy something, every single interaction, it all creates another data point. So the real challenge isn't getting more data, it's making sense of the overwhelming amount we already have. How do we find the signal in all of this noise? So, where do we even begin to make sense of it all? Well, that's where our source for today's explainer comes in. This quote is from a Grade X Teacher's Handbook, which is this really cool collaboration between India's Central Board of Secondary Education and Microsoft. It's designed to give young learners the essential tools they need to navigate this data-rich world. All right, let's try and reframe what data science is. For just a minute, forget about all the complex math. Instead, think of it as a practical toolkit for understanding the world around us. And, like with any good project, the very first step is just getting organized. Think about it. If you're going to build anything, furniture, a meal, you name it, you have to lay out all your parts first, right? Well, in data science, it's the exact same idea. It means taking that messy, chaotic pile of raw information and arranging it into something structured, something we can actually read. So the very first tool in our kit does exactly that. It's all about sorting and categorizing data, and it lets us compare two different things at the same time using a really simple but, believe me, incredibly powerful method. It's called a two-way frequency table. Now, I know that sounds a little technical, but honestly, it's just a grid. You've got one category running down the side, another one running across the top, and the boxes in the middle just tell you how many things fit into both of those categories at once. Super simple. And look at this. See how this simple table makes the data instantly clear? This is from an example in the handbook, a survey on what movies people prefer. Just at a glance, you can see that 16 women liked comedy best, while 14 men went for horror. You also see the totals, that 68 people were surveyed in total, and it was an even split between men and women. All that information just neatly laid out in one little box. Okay, so our data is organized. Now we can start asking some interesting questions. And the first most fundamental question is, where's the center of gravity? What's the single most typical or representative value in this whole data set? Now, to find that center, we've got two main tools. First up, there's the mean, which, well, it's what most of us just call the average. You just add everything up and divide by how many numbers you have. Then there's the median. For this one, you line up all your numbers from smallest to largest, and you just pluck out the one that's sitting right in the middle. So, they both measure the center, right? Does it really matter which one you use? The answer is, oh, yeah, it matters a lot. And knowing when to use which is actually one of the most important skills in analyzing data. And the choice really comes down to this one thing, the outlier. An outlier is just a data point that's so different from everything else that it just sticks out. It could be a typo, maybe a faulty measurement, or maybe a genuinely rare event. But whatever caused it, an outlier has the power to totally throw off our understanding of the data. The Source Handbook gives this perfect example with blood pressure readings. Check out what happens when a faulty machine gives a reading of 180. The mean, the average, suddenly jumps way up to 134.2. That doesn't really reflect what's going on in the other 4 weeks at all. But the median, the middle value when you sort them, is 124. That's a much more accurate picture of a typical reading, isn't it? So here's the big takeaway. When your data has these extreme values or maybe even some errors, the mean can be really misleading. But the median, because all it cares about is that middle position, it isn't affected by those wild swings. It's just a more robust, more reliable tool when you're dealing with messy, real-world situations. So we can organize our data and we can find its center. But there's one more really fundamental piece to this puzzle. We also need to know how spread out the data is. Are all the values clustered tightly around that center, or are they kind of all over the place? The tool for this job is called standard deviation. And look, it's a single number that tells you, on average, how far each data point is from the mean. Just think of it as a measure of consistency. A small standard deviation means your data is all bunched up and pretty reliable. A large one means it's spread out and a lot more unpredictable. Now, the calculation might look a little complicated, but it's really just a logical 5-step process. First, you find the mean.
the center of your data. Then for step 2, you figure out how far each number is from that mean. Step 3 is super important. You square those differences. Why? Well, it gets rid of any negative numbers and makes sure every single distance counts. Then for step 4, you find the average of all those square differences. And finally, you take the square root, which basically just undoes the squaring you did back in step 3. And that's it. You've just calculated a precise measure of how consistent your data is.
And this is not just theory, okay? The handbook points out that standard deviation is used everywhere. Teachers use it to see if a test was fair for all their students. Market researchers use it to check if their survey answers are consistent. And weather forecasters? They use it to tell us how confident they are in their predictions. So a low standard deviation? Yeah, you should probably bring an umbrella. So we've got these 3 fundamental tools, right? To organize, to find the center, and to measure the spread of our data. But, having the tools is only half the battle. The other half, which is arguably even more important, is knowing how to use them responsibly. And what's really telling to me is that the source for this explainer, this handbook for students, devotes an entire chapter to data ethics. It gets that these tools are powerful, and with that power comes a huge responsibility to be fair, to be transparent, and to be unbiased in how you present what you find. And that's really the core takeaway here. These 3 simple concepts we've just covered, organizing data with tables, finding the center with mean and median, and measuring consistency with standard deviation, these aren't just for beginners. They are the absolute bedrock of all data analysis, from a simple spreadsheet all the way to complex artificial intelligence. Which brings us to our final thought. Mastering these tools, knowing when to use the median instead of the mean, or understanding what a high standard deviation really implies, that gives us the power to find patterns and make decisions that affect real people. So the real question isn't just about the math. It's about how we make sure that power is used responsibly. What are the rules we need to build, not just for our algorithms, but, for ourselves?